All right, so let's try to finish up that 4-3. So I'm going to go right to example 4 since example 3. Did we completely finish example 3? All right, so let's do example 4. This is a little different, but it's got a lot of similarities because on the last one, they would ask you, remember they give you that x minus 1 thing, right? It's not always going to be a 1, right? It could be any number, but they gave you that x minus 1, and we had to find out, is that a factor, right, of that particular polynomial? Everybody with me on that? All right, so we could take the k, we could plug it in, right? Make f of k, plug it into the polynomial. If it came out to 0, it's a factor. Or you could just divide, couldn't you? All right, just do some synthetic division, divide. If your remainder is 0, then it's a factor. So that covers the remainder and the factor theorems. So this time, they're not going to give you an option. They're not going to say, is x minus 1 a factor? What we have to do is actually come up with the factor ourselves, all right? And sometimes that has the potential of being a really long, tedious process. But what I've noticed in the problems, because I did the problems in the book, all right, what I've noticed is they're not going to make you, you'll see what I'm talking about in a second, okay? But I'm just kind of starting off here. They're not going to make it where you have to try something like 5, 6, 7, 8, 9, 10 times. All right, because it does. These problems do have that potential where you're going to have to try things a whole lot. You'll see what I'm talking about in a second. But the problems they give you in the book, at the most, you'll have to try things maybe 3, maybe 4 times, all right, before you find the right number that's divisible, okay? So with that said, let's do one of these. All right, so example 4. And I'll write down what the problem says so you know what it says to do. So determine the binomial factors. So it's basically just saying find the factors, okay? And a binomial. What's a binomial? It's a polynomial with 2 terms, right? Binomial. And so like we did yesterday, like that x minus 1 or x minus 2 or x plus 3, that's a binomial factor. That's what we're trying to find. Determine the binomial factors of this particular polynomial of, I'm just going to write it down here, it's x cubed minus 7x plus 6. Okay? So basically what I'm going to do is I'm going to factor this thing. All right? This almost looks like it's an okay thing to factor. But what makes this a little bit of a problem compared to what we've done in the past? Look at it. What don't you like about this compared to, quote, a normal thing that we used to factor? Okay, there's no x squared, but there's also what? The fact that there's no x squared doesn't bother me that much. What really bothers me? The cubed. Right, the x cubed. All right, Gavin, you can just say it. You don't have to tell her. Is that what you did? No? Okay. So anyway, the x cubed bothers me a little bit. All right, so that's where this comes in to be some trouble. So here's what we're going to do. In the problem before, they would say something like, is x minus 1 a factor of this? And so what would you do? You'd put a 1 in for this. If it came out to 0, yeah, then it's a factor. If it didn't come out to 0, then it's not a factor. Everybody got that? But they're not going to do that this time. Okay? You have to figure out what that factor is. All right? And this is how we do it. You watching? What we're going to do is take that last number right here, and we're going to find all the factors of that number. What does that mean? What numbers are being multiplied together to give you 6? All right? So let's list all the numbers. I'm not going to go like 1 times 6, 2 times 3. I just want to list all the numbers. All right? So let's list all the possible factors of 6. What do you think? What always goes into every single number? A 1. 1 goes in every number. And you could have a negative as well. So all these are going to be plus or minus. Okay? I'm not going to write plus or minus for every one. I'll just put it at the beginning. But just realize that every one of these numbers I'm going to write down has a plus or minus in front of it. So 1 divides into 6. What's the next biggest number that divides into 6 evenly? 2. What's the next one? 3. What's the next one? 6. Is there anything else? Is there any other numbers that divide evenly into 6? No, that's it. Would you agree? So that was pretty easy. So what we have is we've got 1, 2, 3, 4, but you also got negatives. So you really have 8 different possibilities, don't you? But like I said earlier, you're not going to have to do like try up to 8 of them, all right? Usually it's one of the early ones, especially in this book, all right? And a lot of math books probably do the same thing. So here's what we're going to do. We're just going to try one, all right? Where are you going to start? Do you want to start at 6? Do you want to start at 2? No, I'd probably start where? At 1. Let's try a 1, all right? And let's get rid of this thing right here. All right, let's try a 1. You could try a -1 if you wanted to, but for me, I would probably just start at 1. All right, so let's put a 1 in for this. All right, so we're going to go f of 1. All right, so it's 1 cubed. We can just do this in our head, can't we? What's 1 cubed? It's 1 minus 7 times 1 is 7 plus what? 6. Check it out. We got lucky, didn't we? First shot. All right, it's not always going to be 1. It seems like it is because every example I've done so far has been a 1 here. Okay, it's not always going to be that way though. All right, so this is -6 plus 6, which I'll just put it here, which is 0. So that means what? That means that 1 is a factor, well, not just 1, but what? Remember, it's x minus k. Remember that? X minus what? 1. X minus 1 is a factor of this thing right here. Okay, so x minus 1 is a factor. Now this one came out way too easy, all right? It's not always going to be your first choice, but I will tell you this. It's usually your first, second, third, maybe your fourth choice, okay? It's usually, in the problems that you have in the book, it's usually not, way out here, because you're going to get some numbers that are bigger than 6, and you got factors all the way out to here. Right? It's usually not the bigger numbers. Usually it's the smaller numbers. But sometimes it's not 1. Sometimes it's -1, so you got to try it again. Sometimes it's not 1 or -1, so what's the next thing you try? 2. You put a 2 in. You keep trying until when you put those numbers in and that thing equals 0. Once it equals 0, then that thing is a factor. Something like this is pretty short. It really wouldn't be that hard, would it, to put other numbers in here? There are actually other factors that you could use. Watch. Put the 2 in for this. Watch this. What's 2 cubed? Let's do this. F of 2. F of 2 is 8, right? 2 cubed is 8. Minus 7 times what? 2, which is 14. And then what? Plus 6. What's 8 minus 14? -6 plus 6. Guess what? So what else is a factor? X minus 2 is also a factor of this. Now, you could sit here and keep doing this, but that's not really what they want you to do. Here's what they want you to do. You find a factor. We know x minus 2 is going to be one of our factors, though, okay? But this is what they do. Once you find this as a factor, what you want to do is take this, the polynomial, the original polynomial, put f of x. Okay, you take the original polynomial, divide it by x minus 1, and then you can go from there. Then you might have to factor it again. But once we divide it by an x minus 1, we're going to get a quadratic. We're going to get an x squared something, okay? And then usually we can factor an x squared, a quadratic, fairly easily, right? We've done a lot of that already. So once I've determined that this is a factor, then I'm going to actually divide it into this. So here's what I would be doing. I'm not going to do the synthetic just yet. I'm going to set it up so you can see what's being divided. You could show it a bunch of different ways. You could show it like this. You could go x cubed minus 7x plus 6 over x minus 1, right? That's still division, isn't it? Okay? But I'm going to do it like this for a reason, because I want to turn this division, this regular polynomial division, I want to turn it into synthetic division, just to make it a little bit easier for us. So this part right here you don't necessarily have to do, but I think it's helpful. So watch, x cubed. Now, do I just write 7x right next to it? Remember, I got to fill in all the place values. Vicky, what am I going to put in here? Okay, 0x squared. Very good. That's what I thought you said. Wasn't sure. So you got to go x squared. If you have an x cubed, your next thing has to be x squared. The reason I asked her because she was shaking her head and I knew what she was thinking. So I just want to give her a chance. So it's 0x squared. And then you can go, there's my x cubed, my x squared. Now I can put my x, which is minus 7x. And now I can put my constant, which is just plus 6. Everybody with me? All right. Now, do I want to do long division like this? Remember the other day we did the long division and it was a mess? Yeah, I mean, we can still do it. It works. Khan Academy, if you watch Khan Academy, he does that. When he teaches this stuff right here and he does this division, he does long division. All right, not sure why. Probably because he hadn't taught the synthetic yet. But let's write this as synthetic division, makes it a little bit easier. So I write it like this. I'll put this little thing. Other people make it look a little different, but this is how I do it. So what am I going to put right here? What's the k? The k goes right here. So remember, this is x minus k. Remember that? What's my k? Is it -1 or is it +1? What did I put into this to make this a 0 to begin with? Nobody talking to me? Or you just don't know? What did I put in for this? I put in a 1, didn't I? So what goes right here? Just a 1, not a -1. I know what you're thinking. You're looking at this and you're like, that's a -1, Mr. Hamrick. Yeah, but it's not x minus -1, is it? It's x minus +1. Would you agree? So that's what goes right there. The k is the 1. Okay, there's the x, there's the minus, this is the k. So the k is 1, so I put a 1 right here. I'm getting blank stares. Does that mean you just don't know, or you're just like, okay, keep going, I already know this? I don't know. It's hard to tell from you guys. Guys used to really give me a lot of feedback, but anymore. Is it just because it's getting harder? Is that what it is? Okay, so let's put in the coefficients. What are the coefficients to this? So you're going to put a 1, then what? A 0, then a -7, and then a 6. Leave a little space, put a line. And now, this is synthetic division. You've done these a couple times already, so we're going to be doing this a little bit more. You'll get used to it. Bring that down, right? Drop it down. And then what do we do with this on the outside and this down the bottom? Multiply them. That's a 1. And then you stick it right here. And what do you do to these two? Add them up, which gives you a 1. Okay? Now again, we go 1 times 1 is 1. We add these up. What do we get? -6. 1 times -6 is -6. And this is a 0. And if you do this right, if you find the correct factor at first, this thing is always going to come out to a 0 remainder. Everybody hear that? If you do it right, the second one, after we do that division, right here, this will come out because it's a factor, which means it comes out and it's evenly divisible, right? I said that a bunch the other day, yesterday maybe. It's evenly divisible, which means it has a remainder of 0. So this should have a remainder of 0. So that's my remainder. This is my what? Constant. This is my x. This is my x squared. All right? So what's this equal to? This is equal to, it's 1x squared, or just x squared. This is plus, because it's positive, 1x. And this is -6. Agreed? Now, what is this being multiplied by? How did we get this? Well, we took this thing and divided it by x minus 1, so I could put an x minus 1 right here. Would you agree that this times this is what we started with? X cubed minus 7x plus 6? Yeah, try it if you want to. But we're not done factoring this yet, are we? Okay, we can do a little bit more. All right? So we're going to factor this thing. Now it's a quadratic. So this is actually an easy quadratic because it's just a 1 out in front. So we can just do just our regular quadratic factoring, okay, if you want to call it that, when your coefficient is a 1. Don't forget this. All right, now we put 2 parentheses. So what times what is x squared? Well, that's easy, x times x. Now, remember the next part? This is just your regular trinomial factoring thing. So these two have to multiply to be -6 and add up to be +1. So what two numbers multiply to be -6 and add up to be +1? Well, that would be a +3 and a -2. Remember earlier I tried that 2 and it worked and I said 2 is a factor? Check it out. There it is right there. I could have tried a -3 as well and you would have found out that -3 is a factor. Let's just do that for fun, right? Just to show you. These are all your factors, right? X what? -1. This technically is x minus what? -3. This is x minus -3. Minus a negative is plus, right? So it's x minus -3. This is x minus what? 2. So 1, if you put 1 into the original thing, right? F of 1 it should come out to 0. If you put f of 2 in for the original, it should come out to 0. And if we put what? F of negative 3, very good. F of negative 3, that should come out to 0 as well. Let's just see if it does, just for fun. Actually, negative 3, right? Is that what I said? Yeah. So what's negative 3 cubed? Negative 3 times negative 3, which is positive 9, times another negative 3, which is negative 27, minus 7 times x, which is negative 3, correct? And then plus 6. Does that come out to 0? I'm running out of room. Let's see if it does. This is what? Positive 21, right? 21 plus 6 is 27. Negative 27. Yep, it does, doesn't it? Okay. So you could have sat there and just tried a whole bunch of things and see which ones are your factors and then ended up with this. You could have done it that way. All right? It's not the way that they kind of want you to do it. Excuse me. But that is one way that you could do it. All right? And then those are all your factors. That's it. That's what they want you to do. So this is the same as what we started with. What did we start with? X cubed minus 7x plus 6. All right? So, well, they could possibly. Let me see what they do. No, it just says determine the binomial factors. So it doesn't say solve for x. It just says find the factors. These are all binomials, aren't they? 2 terms. So that's a factor, that's a factor, that's a factor. Just asking for all the factors. It's not so bad, is it? It's kind of weird. All right, it's a little different. I'm sure you've never seen this before. This is definitely a pre-calc concept, not an Algebra 2 concept. But that's how you do it. We getting it? All right, let's try another one. I think it's a little different, though. Oh, this one's actually kind of easy. Yes. Yep. Yeah, this next one is actually, I think, a little easier. Oh, this, yeah, okay, now I know which one this is. Yeah, this is different. This is a little different, but it's got some similarities to it. So let me write it down. This is example 5. Example 5. Everybody still awake? Okay. All right. Let's write this down. X cubed. Before I write that down, let me write what the problem says. Find the value. Now, this is a little different. Find the value, but we're going to be doing some of the same things. Value of k. Now, this is going to be a little different k than what we were doing before. So that the remainder of this. All right, so the remainder is going to be 0, by the way. Okay, I'm going to put that on the end, but here's what you're dividing. X cubed plus 3x squared. Now here's where it's weird, minus k times x. So I got to find this random number inside this big old long polynomial, right, Kiki? You're finding this k, this little number in the middle of all this big polynomial stuff. And we're going to take that, and it tells you what to divide it by. So that makes it nice, okay? You really wouldn't be able to do it unless they told you what you're dividing it by. And we want to make this thing, the remainder, okay? It's not this divided by this is equal to 0. It means the remainder, I shouldn't even put equals here. I should put is. All right, is 0. I'll write the word out so it doesn't look like an O. Okay? So what I want to do is I want to find out what does that thing have to be in order for me to divide this and my remainder is 0. Well, what do we know about the remainder being 0? If the remainder is 0, we could also, if you look at yesterday's lesson, I think I did things 2 ways. Remember I said method 1, method 2? If you go back and look at that, you could do the division, or you could put the k inside of the polynomial, and if it came out to 0, then we're good. So really, we're not really going to divide by x plus 3. What are we going to do? We're going to go f of what? What am I going to put in? We did this earlier. I'll show you. We did this right here. Remember that? Is 1 going to be a factor? So we put it in for this, didn't we? And if it comes out to 0, that means it's going to be a factor. That x minus 1 is a factor. Okay? You with me on that? And we did the same. Oh, we did the 3 as well. Look, I put an f of negative 3 into this. And if it came out to 0, I know that x plus 3 is a factor of that whole polynomial. So we're kind of doing the same thing. So what am I going to put in to this polynomial? Is it a 3? Remember, this is x minus whatever that is. Okay, it's always the opposite sign. So it's negative 3. So we're putting in f of negative 3 into this right here. All right? Now, the problem is we don't know what that number is, so we're going to have to do a little bit of algebra. It's not much algebra, but we'll have to do a little bit of algebra and actually get k by itself. All right? Because everything's going to be a number, because all I'm doing is I'm sticking numbers in for x. So guess what? I'm just going to be left with a bunch of numbers, and then my variable is going to be k. Everybody see that? Because all the x's are going to be numbers. And then I just solve for k. Should be pretty easy. Now remember, this, if I put a f of negative 3 in for this, what should that have to equal in order for, well, it says right here, the remainder to be 0. It's got to be equal to 0. So that's what we're going to do. All right, we're going to plug a negative 3 in for all this and set it equal to 0. You with me? All right, let's do it. Negative 3. I'm going to write it all out so you don't wonder where we're getting these numbers from. That's 3 times negative 3, that's squared, minus what? K times x, which is negative 3. That's my variable. That's what I'm going to solve for right now. I'm going to solve for k, minus 24, and that equals 0. Everybody okay with that? All right. Now, it's actually kind of easy at this point. Negative 27, that's 9, right? Positive 9 and 3 is plus 27. So you see what happens there, don't you? What's this going to be? Plus 3k, very good. And then minus 24 equals 0. Probably shouldn't put an equal sign right there. So that goes, so what do we have? 3k equals what? 24. What's k? How about 8? Okay. All right. So if you wanted to, and we're going to, all right, if you wanted to, you could check to see if that is correct, right? How would you do that? Well, let's write this thing with the k in there now, all right, because we know what the k is. So let's write it. X cubed plus 3. This is just checking, all right? You don't absolutely have to do this, but we're doing it. We got time. Might as well do it, right? So it's going to be x cubed plus what? 3x squared minus what? Not kx, but what? 8x minus 24. And what are we going to do with this? We're going to divide it by x plus 3. You could do it this way. You could do long division, but I would rather not do that whole long division thing. That's why I learned synthetic division. So now I'm going to do synthetic. So what do we put in this little box right here? This is a key. This is what you always look at me all blank. A negative 3, right. Now we're getting the hang of it. Now I'm seeing a little life in you guys. So this is going to be a negative 3, all right? Now, what's my coefficients right here? It's a 1. Can I just go in order? Yeah, because I get x cubed squared x constant, okay? So I'm good. So that's a 1, then 3, negative 8, negative 24. Now, you should be a little bit more used to this synthetic division, correct? Drop it down, multiply, negative 3. Add up, 0. Multiply, 0. Add them up, negative 8. Multiply, positive 24, it's 0. So it has a remainder of 0, which means what? It means it works, okay? Because when I plug that number in and it equals 0, I should get the same thing when I divide and I get a remainder of 0. So it's starting to click a little bit. Maybe, maybe not. Probably shouldn't ask that question. Yeah, click, click, click. All right. Let's take a look at your homework. All right. The first part is just synthetic division. Well, it's division, but I guess, did they ask you to do it synthetically? Who's got the book? You got the book open on your computer there? Yes. Okay, what's 14? What does it say to do? What's the instructions? Okay, so it does say use synthetic division, all right? So 14 through what? 19 is all those? And that shouldn't be a big deal, should it? Just did one. What's that? I asked you to do those a couple days ago, though, didn't I? I think it was before last night, didn't I? Did I? 14 to 25? Okay. But I think I gave you 14 to 19 the day before that. I said, try these. Anyway, doesn't matter. You still had to do them anyway. Look at number 20. Gavin, what's it say? I don't have a book in front of me. It says find the remainder. Is that what it says? Use the remainder theorem to find the remainder and then state what? Whether it's a factor? Okay, yeah, I just kind of shortened it when I wrote it down. So 20 to 25, you could do it a couple ways, but I did it just one way. I'm going to do a couple of, let's see, let's do 20, let's do 25. Let's do 25, and then let's do 23. I'm going to go backwards because of what the answers are, okay? I want to do one that works, then I want to do one that doesn't work, okay? So 25 does work. So let's write that down. So 25, here's what it gives you. Again, the question says they're going to give you something, and they're going to say state whether it's a factor or not, all right? So they're going to give you 2x cubed minus 3x squared plus x, is that right? Plus x divided by x minus 1. All right. So I have to see, is x minus 1 a factor? If I divide that, will it divide evenly? Well, there's two ways to do it. I'm going to do it both ways. All right? And you can pick whichever way you like. If you're a fan of, synthetic division, feel free to do synthetic division. I mean, you already did a whole bunch of those. But you could also do it another way. What's the other way? F of what? Positive 1, right. It's x minus, and then you always take what's after the minus. All right, so it's f of 1. So if I put a 1 in here, and that thing comes out to be a what? A 0, then x minus 1 is a factor. Okay? That's the first way to do it. There's two ways to do it. You don't have to do it both ways. You just pick which one you like better. All right, so what do you got? 2 times 1, right? Because 1 cubed is 1. Minus 3 times 1 plus what? 1. Let's see if it is. That's 2 minus 3 plus 1. Yep, that's negative 1 plus 1. That's 0. So is x minus 1 a factor? Yes. Okay? Let's do method 2. To tell you the truth, when I did these problems, I did every single one of them by this method. All right? I just thought that was a little easier. But let's just do it another way just to see if it works as well. So what's another way to do this? We could use synthetic division. So what do we put here? A 1. Then what's my constants? Or not my constants, my coefficients. 2, negative 3, and 1. All right? Bring it down. 2. That's 1 times 2 is 2. Add them up. Negative 1. Multiply them. Negative 1, 0. Boom. So what do you like better? Really? Is it really much different as far as the amount of work? No. All right? But it still works, right? It works for both of them. So yes. Now, it seems like every one of the ones we've done so far always comes out to 0, doesn't it? Well, let's find one that doesn't. What did I say we're doing? 23? Yep. So 23. Let's write that down. So what is it? X cubed minus x plus 6. And if we divide it by x minus 2, does it come out even? Okay? So when I say come out even, come out so that there's no remainder. Well, let's do it two ways. Let's try the first way, and then we'll try the second way. All right? They should come out to the same thing if you do it right. So what do we do here? F of what? 2. Right. It's not negative 2. It's 2. So you just put a 2 in for this. Okay? So it's 2 cubed minus 2 plus 6. 2 cubed is 8 minus 2 plus 6. That's 6. That's 6 plus 6, which is what? It's 12. Is 12 a 0? No, it's not. So is f of 2, or is x minus 2 a factor of this polynomial? No, x minus 2 does not divide evenly into this polynomial. All right, so we say no, it's not a factor. Let's try it the other way by synthetic division. What are we going to put here? A 2, right, because it's x minus the 2. And then put the coefficients. So it's 1. Is it? Yes. You got to have a 0x squared, right? Got to have the 0x squared. So it's a 1, it's a 0, it's a negative 1, and it's a 6. Drop the 1 down. That's 2. Add them up. Multiply. Add them up. Multiply. Add them up. Look, they get the same. They get the same answer. Just because they get the same answer, does that means it's a factor? No. All right. But it's kind of interesting, though, isn't it? That's the whole remainder and factor theorem. The whole remainder theorem is that you should get the same number if you put the k into this as you do when you divide them, and that's your remainder. All right? That's what the theorem is telling you. We got it? Okay. So all right, so I'll tell you what. Let me do just one of the other problems. We got time, so I just don't want to waste our time. Let's actually do one. Let's do 28. Is that the next section? Yep. Let's do 28 together. Look, I'm doing a lot of your problems for you, aren't I? Isn't that nice of me? All right, so this says, find the factors. Okay, so you're basically factoring this, and they give you one of the factors. That's nice. You don't have to put the plus or minus 1, 2, 3, 6, whatever, okay? So they give you one of the factors, which is kind of nice. So they say find the factors, or factor. They're basically saying factor this. X cubed plus 7x squared minus x minus 7. We've done this already. This is not really brand new. And it says if x plus 1 is one of the factors. All right? Well, they tell you. They don't say, they're not asking you, listen to me, they're not asking you, is x plus 1 one of the factors? That's what they asked earlier. This time they're telling you what? They're telling you that x plus 1 is one of the factors. And then what do they want you to do to this thing? They want you to factor the whole thing. Okay? So we already know that x plus 1 is one of the factors. So there's a couple things we could do. Sticking a negative 1 in here is really not going to help you. Okay, we're actually going to do the division. So let's do the division. Let's do it by synthetic division. All right? Because you know that's one of the factors. We're not just trying to find if that's a factor or not. That is one of them. It tells you right there is one of the factors. So we're actually going to take this x plus 1 and we're going to divide it by we're going to take this polynomial, we're going to divide it by x plus 1. How do we do that? What do we put right here in that little box? Negative 1, that's right. If it says x plus 1, that's x minus what? Negative 1, so you put it here. Look, 3, 2, 1 constant, we're good, so we don't have to fill in anything. So what do we put for our coefficients? 1, 7, negative 1, negative 7. And now, let's see what we get, because we're trying to factor this. All right. Now, it should come out with a 0 in the remainder, because if this truly is a factor, this will divide evenly. All right, which means you'll have a 0 as a remainder. Drop that down. Let's do the synthetic division. That's negative 1. That's 6. That's negative 6. That's negative 7. That's positive 7. That's 0. So what's my polynomial now? This is remainder, constant, x squared. Remember, this one is always 1 less than that one right there. So this is going to be what? X squared plus 6x minus 7. But that's also being multiplied by what? X plus 1, because that's one of my factors. Now what do? This is very similar to what we did earlier. All right? Because I did an example, right? This is one of the problems that's from the example. So I put x plus 1 right here. Yep, I put parentheses, parentheses. And then I got an x right here. Yeah. Okay. So what do we put here and here? They multiply to be negative 7 and add up to be positive 6. What numbers am I going to use? I only got 2 choices. I got 1 and 7, right? But I could change the signs. So what's my sign? If I'm going to use 1 and 7 and they add up to be positive 6, the 7 has to be positive and the 1 has to be negative. You with me? All right. So, are we done? You tell me. I'm asking you. Why? It said find the factors. Exactly right. And we just found the factors. We good? Keep saying that. Nobody answers me. That's pretty much all your homework problems for this section. I don't even think they give you any homeworks with... I have to look. But at least the ones that I assigned, I don't think they give you... maybe... Let's see. What was that? What number was that one? Oh, no wonder. I got another paper here. So, yeah. So if you go number 32 to 34. Nope. Yeah, so I'm definitely going to break this into at least 2 homework assignments because that's a lot to do. Again, I don't have the book in front of me, but it looks like 32. Gavin, look at it. 32 to 40. Does that look like it's one big section? 32 to 40. What's that? Is it split?
It starts at 29 and goes to 44. That section.
Okay.
It goes to 36. What are you looking at, buddy? Oh, snap.
After 36, though, 37 to 40 is all the same, right? It's 37 to 40, okay. So 37 to 40 will look like this. You just want to do the first one? This way, I don't have to go over these when I assign it. So probably Monday, I'll go over the first part of the homework, and then Monday, I'll give you in class time to work on the second part of the homework. You finish it Monday night, and then we'll be done the lesson. Everybody good with that? I hope. All right, we'll see how it happens. So what did I say we're going to do? 37? Actually, no. I want to do... Let's do one like 31. Let's go back to that. I guess I could start at 30. But I'll do 31. That's an odd one. Odd number. All right, everybody watching 31? I'm doing your homework for you, so you should be writing this stuff down because you're going to have to do this. All right? You got a lot of other problems you can do this too. So this is number 31. And it says basically to factor it. That's what it says. But like the other one, they gave you a head start, didn't they? They told you one of the factors. On this one, they're not going to tell you one of the factors. They're just going to say straight up, factor that thing. All right? Factor that thing. Yes. So it's x cubed minus 5x squared plus 2x plus 8. And they are going to ask you to what? To factor it. I think they might say a little bit more, but that's basically what you're going to do. All right? Excuse me. So what do we do, Sam? Find the factors of 8. So plus or minus. 1 always goes, right? What's the next biggest number that goes into 8? 2. Does 3? No. Does 4? Yep. Does 5? Does 6? Does 7? Nope. But 8 does. All right, so we got to try all those. Agreed? So let's try. What's the first one you want to try? Try 1. Okay? So let's try. We're going to try f of 1. Right? So 1 cubed is 1, minus 5 times 1, right, which is 5, plus 2 times 1, which is 2, plus 8. Does that come out to 0? Nope. Negative 4, that's 10, that's 6. It does not come out to 0. So I'm not going to try the 1. But this is also what? Plus or minus 1. So what do you think the next number I'm going to try? Try minus 1. Try negative 1. You can see what will happen if these small numbers are not factors, right? You're going to have to try positive 1, negative 1, positive 2, negative 2, positive 4, negative 4, until you come to 1. But like I said earlier, they make these problems so you don't have to try a whole bunch of them, right? It's usually one of the early ones, all right? So you won't, but you could see where it could be an issue, right? So let's do this, negative 1. So what's negative 1 cubed? Negative 1 times negative 1 is positive 1 times another negative 1 is negative 1. Minus, what's x squared? What's negative 1 squared? Negative 1 squared. That's a 1. Minus 5. I'm running out of time. I got to finish this. Okay, this is a negative 1, so that's a minus 2, and that's a plus 8. That's negative 5. Oh, did I do that? What did I do? Oh, I was thinking that was a 4. This is negative 6. Okay, for some reason my math left me. That's negative 6 minus 2 is negative 8 plus 8 is what? Yeah, so guess what's a factor? What's a factor? No, x plus 1. X plus 1 is a factor. It's not what they're asking, though. I mean, it's part of what they're asking. It's not the only thing they're asking. All right, so now what do I got to do? I'm going to divide it into this, right? Now, if you wanted to, you could keep putting in these numbers, seeing what comes out to be an 8, couldn't you? And that's one way to do it. It's not how they do it. Probably not the most efficient way to do it. So what I'm going to do is take this divided by, or take this divided by this. Synthetic division, what's going to go here? A negative 1. Take this, 1, negative 5, 2, and 8. Bring it down. Now you should have this down pat, shouldn't you? That's negative 1. That's negative 6. That's positive 6. Oh, did I do that wrong? Oh, no, I did it right. 8. Forgot this is negative. Right, that's negative 8. That's a negative 8. And look at that. That's a 0. So what is this? This is x squared. Look, I don't have to be doing this for you. I could just let you do all this on your own. So we're not done yet because we've got to factor this, don't we? So we got an x plus 1. This is easy factoring. They're not always going to be that easy, but this one is. So x and x. What are we going to use? 4 and 2? Yep. So we're going to go what? Negative, both negatives, right? Negative 4, negative 2. And there you go. It's factored. All right, that's enough. I gave you enough problems. Man, I did. Well, not half, because I gave you a lot to do. So what was the first homework I gave you? 28 to 34, 37 to 40, right? No, I gave you 14 to 25, right? Okay, so I'm going to take 14 to 25 from you, and then your homework is just, I'm just going to give you, listen, I'm just going to give you 28 to 34. So I'm only going to give you the first part, 28 to 34. All right, so this is due Monday. Okay? And then on Monday, I'm going to have you do 37 to 40 in class. Everybody got it? 37 to 40 in class. And then on Tuesday, I think we'll be ready to do a new lesson. All right, look at that. Good timing. Bell just rang.